Great show. Only one train downstairs.
Do, 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 do,
Oh, you
do.
can't see YouTube. It should be there. Or maybe it is there. Ah. Oh, there it is. Great.
La 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 la. All right, guys, welcome, welcome. All right, everybody. So, welcome to Math Tuesday this week. We've got a little geometry problem here for you to figure out. So, whenever you figure out the value for x, just pop it in the chat and we'll get into it. We're going to be doing a whole lot of geometry tonight. Doing a lot of geometry this week. Because that's what I'm teaching this week. Well, that's what I'm giving tests and quizzes on this week and next week. So I want to kind of work out some of the problems. All right, so Brazen got 40. Let's see. Ooh, combinatorics. So we primarily stick with like algebra 1, pre-algebra, geometry, algebra 2, some trig, but we don't really get into combinatorics. But if you put your question in the chat, if you have a specific question about it, you can put it in the chat because we have a really good community here and somebody might be able to help you out. Okay. All right, so we've got this geometry problem here. We're trying to figure out what x is. Using the information that's given in this. Oh, okay. So the highest math I know or the highest math that I teach? So, I mean, I took 3 years of calculus in college, so like I can do that, but I choose. I mainly we focused on like pre-algebra, algebra 2, trig, stuff like that in here. Oh, Lindsay, you're back with the insane geometry problem. I do remember you. How'd that work out? Ooh, we've got a lot of 40s and we got a lot of 70s. All right, Shelly Brady over on YouTube said hi. You never figured it out. Lizzie, neither did we. I feel like a lot of people, like that thing was a beast. Oh, Sebastian, you're in luck. I don't usually do proofs, but I'm going to do a little bit of proofs today. Oh yeah, Lindsay, if you haven't saved, I think some people might be curious to see what this doozy of a problem was. Okay, so guys, so like I said, those of you who are just joining us, I'm Sarah. I like to do math every week. I do math every day. I mean, everybody does math every day, right? But so this week I'm doing a lot of geometry because that's what I'm working on in my classes right now. But if you have questions about anything specific, we can get into it, okay? Okay, so right here, let's talk about what's going on in this diagram. Right, we got a couple of things. We've got this exterior angle out here, and then we've got this triangle here. Now, this is an isosceles triangle here. The way we know it's isosceles is because these two side lengths are congruent. Now, if these two side lengths are congruent, what that means is that these two angles are also congruent. Okay, so that the angles that open up to the sides are going to be the same also. So this one up here is also x degrees. Okay. Now this one right here, this 140, this right here makes a straight line. So if that side is 140, this side in here is 40 degrees. because 140 and 40 makes 180. Then we've got these three angles that are going to add up to 180. So I've got x plus 40 is going to add up to 180 because all triangles add up to 180. So 2x plus 40 equals 180. So 2x equals 140. So x equals 70. So my x value is 70. Okay. Now, what you can also do is, I saw a lot of people saying that 2x equals 140, which is true. That's the exterior angle theorem, exterior angle, yeah, just exterior angle theorem, I believe. But it's where these two interior angles will add up to that exterior angle right there. Okay, so these two added together is 140, but you can also see like this kind of proves that that's also true. Okay. All right, so let's take a look at, so I've got a couple of geometry problems here that I want to try, just because they're questions that I'm going to, that I'd like to give to my students later this week. And so we're going to try them out here. Okay, let's see. All right. Pancake Mix, hi. I know you've said hi to me a couple of times, and hello. Okay. Oh no, PNAV, I'm sorry. Let's see, Anaya asking for vectors. We're probably not going to get into vectors. Let's see. Oh, Trey, that's too bad over on YouTube. You don't have to be here. You don't have to do math. You can keep scrolling, buddy. Okay. Let's see. Excel, it kind of depends on what college math you are asking for. Okay. All right. So we've got a lot of people asking for sine and cosine and tangent. We can get into trig. Oh my gosh, Emily, related rates. Related rates are tricky. Are you doing it with, we are not going to get into it with related rates because it's a little too much for this, but all right, so similar triangles. So we're doing a lot of similar and congruent triangles tonight. So similar versus congruent. Okay, actually, I want to work through this. So there's some problems. So this is kind of one of those things that you may not see from a teacher very frequently. But when we're getting ready to give you problems, when we find problems from somebody else, right? Somebody else has written them or there's a worksheet or something like that. We usually, almost always, we go ahead and we work these out on our own. So I was trying to find some problems for my students to work on this week. And I came across this worksheet that had a whole bunch of these, okay? Oh, and then what we're given is triangle ABC is congruent to triangle DBE. Okay. Not drawn to scale, obviously, right? And so we're trying to figure out X. All right. Oh, Trey. Okay. So Trey, I teach primarily high school, so 10th and 11th grade is what I usually teach. Oh man, Rebecca, we've got a whole big setup in here. I've got a camera right up there. Woohoo! It's up on a tripod, and then I got a mic. I got another camera there. It's all over the place. Okay, so let's take a look at this. So I was looking at this one and I was trying to figure it out. So we've got A, B, C is congruent to D, B, E, which means A, B, C, and D, B, E. It's obviously way not drawn to scale. And I'm wondering if these might actually be, okay, so this angle and this angle are congruent. And the reason I know they're congruent is because B and B, right? So A, B, C is going to be the same as D, B, E. So these are congruent. Okay. So this is 30, this is X. I don't know what that is. I know that these two are the same. Gosh, I don't know if there's enough to figure this out. Because there aren't any vertical angles. Okay, so Kevin, you're saying angle D is 70. How do you know angle D is 70? Okay, so D is 30. Oh, right, because A and D, got it. Okay, so 30, yep. So that's 30. So then that's going to give you, so that's 110 and that's 70. So that's 70. Okay. So then, let's see, A and D. So C and E are the same. So that means that this whole angle here for C is 80. So this whole angle here is 80. 70, 180. Okay. So now we've got CEB should be 150. So CEB should be 150. How do we get 150 for CEB? Why is D 30? Oh, okay, so D is 30 because A is 30. And right here we've got A and D. These are congruent because it says that these two triangles are congruent. Okay. E is 80. Yep, E is 80 because we were given E is 80. So E is 80 and the whole thing of C is 80. But now how to figure out so 70, 30, 80, 70, 30, 80. So this is 140. This is 30. That's 170. Let's see. Wait, let me see. Somebody put this up. $180 minus 70 equals 110. So here's the problem that I'm having though is, so Miles, I don't know. So 180 minus 70 is 110, and then 110 equals 2, or I'm sorry, 110 divided by 2 is 55. But I don't know. There's no reason for me to divide it by 2. $180 minus 70 plus 80. So that's going to give me 30. C and E. So C and E are congruent, and that's how we got that this one is 80. But the problem is that with C, this C is talking about angle, really angle BCA. So it's talking about this whole angle. So this is X. So 360 minus 80 minus 30. So angles in a quadrilateral. Okay, let's see. Amarosa, I think that's your name. So slopes, remember, they're not too challenging. Just remember that it's rise over run. Okay, so we're getting x equals 60. See, I'm just not sure how we go from here. It's 70, 80, 30, 70, 80, 30. So the problem is this piece in here, right? We need to figure out what all of this is. So I know that these two are going to add. Oh, well, that's not really going to work. Well, maybe I can start. X equals 10. Let's see, the angles from the figure ECDB is 360. Yep. So this would be 110 minus X, right? This would be 180 minus 110 minus X. So that would be 70 plus X. I don't know what I'm doing right now, guys. I don't know. And this is going to be 80 minus X, but that's not going to give me anything. Because those are just going to cancel out. And that won't give me X. Because see, if I do this minus X and plus X, that's just going to cancel out. Let me see. X equals 10 because 80 is an exterior angle. So this 80 is not an exterior angle. This 80 is this whole C angle up here. Oh, if we had a side length, that would be nothing. Okay, so can't you draw a continuous line? Triangle EBC isosceles. Is EBC isosceles since BC and BE are corresponding sides of a congruent angle? So, AB would equal DB. And BC would equal BE. That's an interesting idea. If they were isosceles, well, they're not going to be isosceles, but they are congruent. So that means that if DB and AB are congruent, yep, okay. So then BC and EB, I don't think that's going to help anymore. Let's see. We get X equals 60 because angle BEC is 50. Angle BEC is 50. How'd you get BEC is 50? And angle AEC is 130. So this 80 here is not an exterior angle because this line does not continue on. Okay, so I see x equals 10 if the 80 degrees on point E is vertical to angle AEC. I don't think they're vertical. The way the diagram is not vertical. Draw the horizontal at C. So we don't know anything about these being parallel or anything like that. So EB does not equal EC. EB equals CB. So EB equals CB. All triangles do add to, I'm thinking we don't have enough info. It is so challenging yet so fun. I agree. Yep, so the exterior angle, but we don't have any exterior angles. That's the problem, is that we don't have any exterior angles, and I don't have anything that's parallel. So angle ACE, okay, wait. Angle ACE is 180 minus, so angle ACE is 180, whoop, 180 minus 110 minus X. X equals 60. So, but here's the problem, Mr. C or MRCL, I can't read what your name is. But when you add those together, if you do, so that's what I was starting to do, is that this would be 180, right? This would be 180 minus 110 minus X, right? And then this up here would be 80 minus X. But what happens is when I add those together, I would have 30 plus 80 minus X plus 180 minus 110 plus X. Those X's are going to cancel out. So that's why I kind of moved away from that. Is that they start to just cancel out. I don't know, guys. I think we might be out of luck on this one. Let's see. Wouldn't the angle of E be the angle of the entirety of AED? I'm not sure I fully understand. So all of E is an 80. So it's not all of E, it's BED. Okay, so Ryan or Ryan, that's what I was kind of looking at. Okay, let's see. This is geometry, yes. Let's see. Okay, so if CB is equal to EB, then triangle CEB is isosceles. So that's what I was kind of looking at. So if CB, all right, let's look at this. So CB is congruent to BE. Okay. And then AB is congruent to DB. Okay, I don't think we necessarily need to worry about that. Okay, this might work. Okay, because So EB is congruent to CB. And since this is a share, since this is going to be the same side. Oh, I see. A lot of you were saying that X is 55 because you just kind of divided that in half. And now I see where you were getting the 110. I didn't see it before. Okay. So because, oh my gosh. I think we cracked it. Good job. Okay, so because these are two sides that are congruent, right? This one, CB and BE, because that's isosceles, that means that this angle is also X. So 110 minus 70, or sorry, 180 minus 70 is 110. So X is 55. And I know there were so many of you that said that like 10 minutes ago. But we finally got there. It's hard to scroll through everybody's comments. Okay. Okay. All right. Let's do another one. Let's do another one. Okay. All right. Let's get another diagram up here. Oh. Some of these diagrams are gross. Okay, ooh, this is the one that I saw that I really wanted to work out with all of you. Okay. All right, let's see. Remember, not drawn to scale. Okay, so we've got this, and this, that. Almost looks like a fish, huh? So we've got C, A, D, E, B. Okay, so this measurement is X degrees. Oh wait, this should not be here. This is not supposed to be here. There we go. And this one's 32 degrees. Okay. A couple of things that were given is AE bisects DAB, angle DAB. And then we have CE bisects ACB. Okay, so we don't know. Yeah, there was some little blip. I don't know what happened, but I think we're good now. So AE bisects DAB. So that means that this angle here is also X degrees. Let me use the darker blue. It shows up a little bit better. So that one is also X. And CE bisects ACB. So that means that these are also congruent. Jack, you got a 96 on your test. That's awesome. The intersection of AB and EC, it does not indicate that they are right angles. No, we can't assume anything. This is all we have to go for, or to go off of. Okay, so Vidisha, how to find the area of a composite figure. Chop it up into like rectangles or squares or any, chop it up into its pieces, into its parts, and then find the area of each of those and then add them up. So same thing, Vidisha. Anything that's composite, you just chop them up and you just figure out the parts of it and then add them up. So this line, these are not indicated to be right angles, okay? So now we know that, let's see. So we do know that this one is 32 plus x. I know that this one here is 180 minus 2x. Right? Because those would add up to make a line. And I know this one is 32 plus x because these two add up together. Okay. So stretch out, make corresponding angle, and solve it. So Jojo, these are the givens, that AE is an angle bisector and CE is an angle bisector. And I don't know that this is perpendicular because otherwise we could do like a kite or like do the isosceles, right? So we've got that angle, we've got this side, and I don't know about these angles. So we know it's 32 plus x because this is an exterior angle and it's going to be these two added together. So the remote interior angles add up to make that exterior angle. Corresponding angles are congruent, but right now we don't have anything parallel. So then, I wonder what happens if we do this one is 180 minus 180 minus 2x minus 32 plus x. I wonder what happens if we do that. Because if this, so if these, get triangle AEC. Oh, AEC might be a little bit simpler. So if we look at triangle AEC, well, no, because then those X's are going to cancel out. Okay, so I'm going to try this one. So angle, I guess ACE. So angle ACE is going to be 180 minus this angle, which is 180 minus 2x, and minus this angle, which is 32 plus x. So let's see how that shakes out. So we've got 180 minus 180. Great, those are gone. So then we've got 2x minus 32. Oh, but that's not going to give me an x. Wait. Wait, hold on. What am I doing? Well, kind of worked. Okay. It kind of gave me a little bit of information maybe. So then ACE is x minus 32. Maybe. So x minus 32. No, but then when I add those up, they're all going to cancel out again. The middle angle here. Oops, sorry. Didn't realize it was so crooked. So the middle angle, are you talking about this angle here? 180 minus 32 plus x? So that would be 180 minus 32 minus x. So that would be 180 minus 32, which is 148. Would be that one, right? Because then that makes sense, because then if I add those up, they're going to cancel out and it's going to be 180. Yeah, vertical angles are congruent, so we'll do 148 minus x here. But these are all going to cancel out. So let's go back and think about this triangle ACE. Somebody said earlier with like AEC or ACE. So, oh, what does bisect mean? So bisect means that it's cutting it in half. So AE is bisecting angle DAB, which means I'm cutting it in half. So that's how I knew that these were both X. Okay, so it means cutting it in half. And same thing with CE. I know that these two angles are going to be congruent also. Okay, so let's try. See, that's going to all cancel out. So if we do x minus 32 plus 32, those cancel out, so now I'm just x. Plus x, which is 2x, plus 180 minus 2x. That all cancels out and says 180 equals 180. Interesting. So Jojo, we're just trying to figure out what this x value is. So what I'm going to do is I don't want to completely erase everything, but let's start a little bit over. Let's clean this up and let's see what we've got here. Okay, so here's what we've started with. Here's the problem that we started with. For those of you just joining us. We've got this here. All right. So AE bisects DAB. So that's how we get that this angle here is also X. And then we have CE bisects ACB, which means that these two are equal to each other. Okay, we can call that y, sure. Let's do y and y, sure. So we are just trying to figure out what x is. So I know that, let's see, if that's 32 and that's x, so 180 minus 32 is 148. So this one here is 148 minus x. And then this one here would be 32 plus x. So this would be 148 minus x. And then this one up here is going to be 180 minus 2x. Okay, so then Angle Y is going to be 180 minus 180 minus 2x minus 32 plus x. So 180 minus 180. All right, so y equals, we've got 2x minus 32 minus x. So that means that that's going to be x minus 32. So y is x minus 32. Pinty, you think it's unsolvable? Okay, so then what if we did... See, but it's going to get back to the same thing. Okay, so what if then we do EAC, right? We say that... Oh, wait a minute, though. Oh, that work? Oh, that would be the same. It's just a circular argument. Okay, well, let's see. So if we do y plus 32 plus 180 minus 2x plus x equals 180. So then we could subtract the 180s. So then we've got y minus x equals, see, but that's going to be a circular argument. These are the same thing. Y minus x equals 32 and x minus 32 equals y. Wait, that's not the same thing. Equals negative 32, sorry, negative 32. Right, so I'm wondering if there's, so this is an angle bisector. It feels like there's something missing. Find angle B. So angle B would be 180 minus 148 minus x minus y, right? 148, oh, sorry, 180. Minus 148 minus x minus y. So that's going to be 32 plus x minus y. Is that going to be 64? Is that right? I don't trust that. Right, so Gaffel, it does not say that they're parallel. And it doesn't say that these are perpendicular, because otherwise we could use like a kite or something like that. No, you're not cooked for your Algebra 2 test. Okay, let's take some requests. I'm not sure. That's awesome that you're learning in the 8th grade. You're done for your geometry midterms? Luke, I know the public schools around here do M-Step. But we're at a private school, so we do the NWEA, which the public schools do that also. Okay, let's see. But Gaffel, sure. Georgia Phil, I don't know. Solve for y and x will be a corresponding angle. It's not a corresponding angle though, because I don't have it. I don't have parallel lines. Yeah, I don't know, guys. I don't think we're gonna figure that one out tonight. I think there's something missing. I think there's something missing about it being perpendicular or something like that. All right, so let's graphing logs, yikes. Oh, baller, yes, let's talk about even and odd functions. Okay, so an even and odd function, that's when we're talking about like a polynomial, okay? So when we're talking about a polynomial, okay, so when we're looking at it with the even and the odd, okay, so usually when you first learn these, you are talking about with polynomials, okay? So with something like, and an even and odd is the easiest to tell when you've got the degrees, okay? So if you're first learning these, okay, so if I've got f of x equals 3x to the 4th plus 5x squared minus 2x plus 1. Okay, so something like that. So this is an even function because we have an even degree here. Okay, now what that means, what usually you're looking at is the end behavior. Now the end behavior of an even function means that you're going in the same direction. Okay, so the end behavior for an even function is going to do two things. It's going to be pointing in the same direction, okay? So either both ends are pointing up or both ends are pointing down. So they're either going to both be going up like this or they're going to be going down like this, okay? Now, all the stuff in the middle, that all comes from down here or whatever else is going on in that polynomial, okay? There might be some squiggles like that, right, and things like that. But ultimately, okay, it's going to end up where the ends are going down, both down or both up. So that's an even function. Okay, now to figure out if they're going up or down, you look at this first coefficient, the leading coefficient. If the leading coefficient is positive, they're pointing up. If it's negative, they're pointing down. Okay, so then an odd function is where you would have something like this, where you've got this odd degree, okay? And what this means is that they're going to be pointing one up, one down, one up, one down. So they're going to be pointing in different directions. So again, it's primarily just with the end behavior that you're really paying attention to. So either it's going to be going up, one down like that, or one up, one down like this. Okay. And again, to figure out if it's increasing or decreasing, you're going to look at that leading coefficient. So here, this leading coefficient is negative. So the way that I like to think of it is it's sort of like a negative slope goes downhill from left to right. So just like this, right? This is like a negative slope here. So if the leading coefficient is negative, it's going to be going down this way. If the leading coefficient were positive, it would be going up this way. Okay. So those are really kind of basic ways to figure it out. Now, if you go beyond that, you're going to be looking at sort of like the symmetry if you're looking at the actual graph itself, okay? So there's a couple different ways, like algebraically and symmetrically and things like that. But if it's even, let's see, so even and odd, okay? So this is just when you're looking at just a polynomial function, okay? Just a polynomial function, you look at the degree, if it's even or odd, and then you look at the leading coefficient, it's positive or negative, whatever that is, okay? So if f of negative x is still the same thing as f of x, then it's even. Okay, which kind of makes sense. Like if you think about like, well, if I put in 2 and negative 2 and I'm squaring it, I'm going to get 4 no matter what, right? No matter what. So that's going to be an even outcome. Okay. Now, if f of negative x is the negative outcome of f of x, okay, then the function is odd. Meaning like if I put in negative 2 into x cubed, that becomes a negative 8, right? So that's because it's, yeah, like a cubic root sort of, yeah, okay. And if it is neither even nor odd, okay, that's possible, right? So if f of negative x doesn't equal f of x or it doesn't equal negative f of x, then it's neither. So there are some other like ways that you can talk about the end behavior, okay? Things like that, but most of the time, again, when you're dealing with polynomials and stuff like that, the functions are going to be positive or negative or even or odd. Just based on the degree and the leading coefficient. Okay. All right. Let's see. So Issa, transformations and how it affects the x. Do you mean with transformations of like quadratics or linear functions? What level are you talking about? Like with the parent functions and all of that? So Luke, a geometric sequence, do you mean like you multiply each one by like each term by the same number? So like you're multiplying everything by 3, right? So it'd be like 3, 9, 27, right? That you would be multiplying all those. Okay, so transformations of cubic just polynomials. Okay, so the transformations really, I mean, so transformations, there are a couple of different things that you can look at, right? So transformations of any function is so trying to think of like kind of big picture. So transformations of any function, they kind of fall into the same categories. There's a lot of different ways that we can do transformations, but ultimately they kind of fall into the same idea. Okay, so if we take the parent function, right, which is just like y equals x cubed, right? That's the parent function of a cubic function. Okay, but I can do a couple of different things to it. I can put a number in front of it. I can put a number in front here. And then I can put on a number down here. Okay. Now, this value here, okay, if it's negative, it's going to be a reflection over the x-axis always. Okay. So that's going to be the reflection. Okay. This a value is a vertical stretch or shrink. Okay. Yeah. So the reflection is just if a is negative. Okay. So this is a vertical stretch or shrink. This here, this h value, see ya, this h value is going to be the horizontal translation, which is just a shift, right or left, right to left. Now h, in any transformation, h always lies because it's a minus h. So if it's x plus 2, it actually means that it goes to the left 2. If it's x minus 2, it actually goes to the right 2. So h always lies. Okay. And then k, oh, sorry, hold on, guys. I gotta do my little thing, my puzzle piece. Okay. K is your vertical shift, up or down, and K tells the truth, okay? So H always lies, but K is always going to tell the truth. Okay. Now that can go for pretty much any parent function. So any transformation, like the H is the horizontal, the K is the vertical shift. Yep, K is just like it says. A is that stretch, right? It's going to stretch it out or shrink it down. Okay, that B value there can also have something to do with the vertical stretch and the shift and everything. And then the negative or positive with this A, this is just a reflection. Okay, so it's either going to flip it over the x-axis or not. Okay, but ultimately those are the transformation rules. And K is just like it says, yep. All right. Ooh. Excuse me. Okay, so Isa, is that helpful? Okay. I know it's kind of hard, and what's really difficult is when you're just kind of given a graph and you're supposed to write the transformation. That's really tough, right? And it can be tricky to, I prefer, what I like doing is with these, doing like a matching question. So the B isn't even always there, right? It's just kind of having to do with a little bit more of like the stretch and the shrink. Usually you don't even include that B value there. But it's just like if you can't kind of factor that out. Okay. And there's a little bit more that goes into it, right? Like the A value, I went to a thing last year, I think, at a math teacher conference where we were sort of investigating like what this actually does. And we were kind of playing around with it on really fancy like TI calculators that were basically computers. And they were just kind of showing, like, we were scanning through these different values for the A, because it was like, what does it actually do? And there's a lot that goes into it. It's not just stretching and condensing. It's kind of like turning it also. There's a lot of motion, a lot of movement that goes into it. All right, guys. Well, it has been a delightful hour. Yeah, you can play with what it looks like on Desmos. That's really fun too. I don't know. if Desmos will do like a cycle or an animation. I bet it will if you put in a bunch of them or something like that. You can probably set it to do an animation on there, which would be pretty cool. All right, guys. I will be back next week. If you have any more particular questions, you can always reach out to me and let me know. All right. Have a good night.